Today we're going to discuss how to find the minimum or maximum value of a parabola. So remember that when we have a parabola in standard form, so it's ax squared plus bx plus c, we look at the a value to determine if the parabola opens up or down. So in this case, the a value is -4. That tells me that the parabola is going to open down. So this is its highest point, which is also known as its maximum. It does not have a minimum because it is going to continue down forever. Where the maximum is located is at its vertex. So in this example it says, tell whether the function has a minimum or maximum value. We have established that it has a maximum value. Now it says to find the value. So how we find the value is by finding the vertex. So since we are in standard form, we can use the formula -b over 2a. So we have negative, b is -24, over 2, and a is -4. So on top, that simplifies to 24, and on the bottom is -8, which reduces to -3. Now this is not the maximum point. I need to plug it back in to find the y value of the vertex. So in my calculator, I would plug in -4 times -3 squared minus 24 times -3 minus 19. And that would get me 17. So the vertex of this parabola is at -3, 17. The maximum value is the y value of the vertex. So when it asks you what is the maximum or the maximum is 17. Let's try one more problem. So over here, our a value is 3. This tells us that our vertex opens up. When the a value is positive, our parabola opens up. So the vertex is right here, and this is a minimum value. It is the lowest value on the parabola. So what we can do to find the actual minimum is go ahead and use the formula again, -b over 2a. So negative, b is -2, over 2 times a is 3. So I get 2 over 6, which is 1/3. Now, we need to go ahead and plug 1/3 into the parabola to find the y value. So we would type in a calculator. 3 times 1/3 squared minus 2 times a third. And that gets me -1/3. So what that means is the vertex of this parabola is at the point 1/3, -1/3, and its minimum is the y value. That means the lowest this parabola goes is -1/3. So to answer this question, we would say that it has a minimum, and the minimum is at -1/3, and that's the lowest point this graph will reach. Okay, now let's go ahead and let's look at a word problem. So this problem says the suspension cables between two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by this equation. X and Y are measured in feet. What is the height of the cable above the water at its lowest point? So we need to get a visual of this. What they're saying is you have two towers, and then there is a suspension bridge. So the cable suspends, and that's part of what supports the bridge. So they're saying, what is the height of the cable above the water at its lowest point? So your water is down here, and its lowest point would be its minimum right here. And we know when we're looking for a minimum, that means find the vertex. And how we find the vertex in standard form is we use -b over 2a. So we are going to go ahead. We have negative, b is -0.37, over 2 times a is 0.000098. So now if we plug that into our calculator, I went ahead and typed in 0.37. I went ahead and typed in 2 times 0.000098 and got 0.00196. I typed that one more time into my calculator and got 1,887.8. Now that is not how high off the water that is how far to the right of the first tower. So it means that if you think about this as being on an XY axis, then this is the X value of the vertex. So that means it comes in 1,887 feet before it hits its lowest point. So to find our Y value, we're going to plug back in 1,887.8 into our equation. So when I plug that into my calculator, I find out that when I plug in 1,887.8, I get 202.8. that y value is my minimum. That means that's how high above the water the vertex is. So what is the height of the cable above the water at its lowest point? It's 202.8 feet above the water. Let's go ahead and look at another example like the previous one. This is about the Tacoma Narrows Bridge in Washington. It also is a suspension bridge, so it forms a parabola, and the equation is shown in the problem. And it once again establishes that x and y are both measured in feet. Now it asks us to find the minimum, okay, the lowest point. So that's the minimum. That is also known as the vertex. Anytime we want to find the min or the max, we should immediately think, okay, that's the vertex. And how we find the vertex is by using the formula negative b over 2a. So we figure out what our b value is and what our a value is, and then we will plug this into our calculator. I go ahead and I simplify so that when I plug in, I don't have as many errors. So I just go ahead and I make this be positive 0.46, and then 2 times 0.00016 is 0.0032. So then I type that in my calculator again, and I get 1,437.5. Now remember, that's not our answer. That is the x value of our vertex. So that is how far in the minimum point is. So it is 1,437.5 feet horizontally distant from the support. So to find the height it is above the water, we need the y value. So we plug in 1,437.5 into our equation where x is. We type this into our calculator and I get 176.4. So what this tells me is that at its lowest point, the cable that is supporting this bridge is 176.4 feet above the water. Okay, our final problem is comparing 2 different water balloons that are being launched. So the first water balloon is modeled by the function that is shown right here. It represents the height of the first water balloon, and t is the number of seconds after it is launched. The height of the second water balloon, t is also seconds, is shown in this graph right here. So it says which balloon went higher. So what I'm going to do to find the highest point, that's the maximum, which once again means find the vertex. So first, for function f, I'm going to go ahead and find the vertex. I'm going to use the formula negative b over 2a. Now, since the a value is negative, I know that it has a parabola that opens down, therefore it has a maximum. So I'm going to do negative b over 2a. And I'm going to get negative 80 over negative 32, which is 2.5. Now I'm going to use my calculator, and I'm going to plug 2.5 in for t squared and for t. When I do that, I get 105. So that means it took 2.5 seconds for the water balloon to reach its max height, which was 105 feet. So now let's compare that to the second balloon. We're going to do a little bit of estimating here. But it is clear right here, this would be 3 seconds. So just before 3 seconds, the water balloon reached its max height. Let's call it 2.9. Now for its max height, we also need to estimate this. This graph is going by 25. 25, 50, 75, 100, 125. And I can tell this is above 125. I'm just going to estimate and say that I think it's maybe around 130 if I had to guess. So clearly, this water balloon, the second one, went higher because it, at 2.9 seconds, reached its highest height, which was 130 feet. So the second water balloon went higher. Now, which balloon reaches its maximum height faster? That is the t value. So this is the t value, and this is the height. So the first balloon reached its maximum at 2.5 seconds. The second balloon reached its maximum at approximately 2.9 seconds. So the first balloon reached its maximum height faster. And it wants us to explain. So I will just say it reached its max at 2.5 seconds. And the other balloon reached its max at 2.9 seconds. And that would be my explanation.